The year 1118 witnessed the culmination of a remarkable intellectual journey, a testament to the enduring power of human curiosity and the relentless pursuit of knowledge. In that year, Omar Khayyam, the multifaceted Persian polymath, completed his seminal work, the Treatise on Demonstrations of Problems of Algebra. To fully appreciate its significance, we must first situate Khayyam within the intellectual currents of his time and explore the specific problems he sought to address. Before Khayyam, the field of algebra was largely dominated by rhetorical methods, relying on verbal descriptions to express mathematical relationships. The work of the Greeks, while foundational, had limitations in systematic algebraic manipulation. The burgeoning Islamic Golden Age, however, provided a fertile ground for mathematical innovation, drawing upon Greek, Indian, and Persian traditions. Al-Khwarizmi, in the 9th century, had already made significant headway, introducing the word algebra itself and developing methods for solving linear and quadratic equations. However, these methods, powerful as they were, lacked a general methodology for solving higher-order equations, particularly cubic equations. This was the landscape Khayyam inherited, a landscape ripe for exploration and innovation. Khayyam's treatise went beyond Al-Khwarizmi's achievements. It aimed for a systematic classification of equations, moving beyond the limited scope of linear and quadratic forms. Khayyam categorized equations based on their degree, providing geometric solutions, primarily utilizing conic sections. This approach, elegantly marrying algebraic problems with geometric constructions, offered a powerful means of visualization and a pathway to understanding solutions that were, at the time, inaccessible through purely algebraic methods. Consider, for instance, his method for solving cubic equations. He recognized that these could be geometrically represented as the intersection of conic sections, parabolas, hyperbolas, and circles. The roots of the equation would then correspond to the points of intersection. He masterfully demonstrated how to construct these conic sections, thus providing a geometric solution to the algebraic problem. This geometric approach, so counterintuitive, initially sent shivers down the spines of even the most seasoned mathematicians, representing a significant leap forward in mathematical thought, a pivotal moment bridging algebraic and geometric perspectives. The specifics of Khayyam's geometric constructions, a remarkable example of his ingenuity. He tackled 13 distinct types of cubic equations, providing geometric solutions for each. These solutions, detailed and meticulous, demonstrated a keen understanding of geometric principles. He provided clear instructions on how to construct the necessary conic sections to determine the roots of each equation. He achieved this through the application of Eratosthenius' method for doubling the cube, a problem that had perplexed mathematicians for centuries. The geometric constructions and his insightful analysis of the problems, including discussions of multiple solutions, underscored his profound understanding. He delved into discussions of negative and imaginary roots, though he dismissed these. His treatment of these higher-order equations represented a major advance. The immediate impact of Khayyam's treatise was profound, though not immediately widely disseminated due to the limitations of scholarly communication in the 12th century. It served as a beacon for future mathematicians, a roadmap for approaching complex algebraic problems. While it may have taken time for his work to become universally recognized across the existing scholarly landscape, it provided a fundamental contribution to mathematical methods. The work's significance was largely appreciated by other scholars of the period. Khayyam's treatise did more than merely offer solutions to cubic equations. It laid the groundwork for the development of algebra as a distinct field of study. His systematic approach, his meticulous classification of equations, and his insightful use of geometric methods established a model for future mathematicians. He provided a framework, a language, and a set of tools that would inspire and influence subsequent generations. Al-Khayyam, an earlier Persian mathematician, had made significant contributions to algebra, and now Khayyam advanced this work. Taking algebra, the influence of Khayyam's work can be traced through the centuries. His geometric methods for solving cubic equations remained a significant contribution to the field for hundreds of years. Many later mathematicians, across various cultures, drew inspiration from his systematic approach to problem solving. His work shaped the development of algebraic notation and the understanding of equations of higher order. Over time, Khayyam's influence extended beyond the immediate confines of mathematics. His emphasis on rigorous demonstration and logical deduction, as seen in his treatise, exemplifies the importance of reason, logic, and precise language. These hallmarks of Khayyam's method influenced many fields, from the scientific inquiry to philosophy. Khayyam's treatise has been subjected to various interpretations. One major point of discussion concerns the limitations of his approach. While his geometric methods were powerful, they were inherently tied to visual representation. They did not easily lend themselves to the development of abstract algebraic manipulations. The reliance on geometric construction sometimes made the solutions cumbersome. It was a step forward, an essential one, but it was also a step restricted by the technological and conceptual limitations of his era. Another aspect that has drawn attention is his treatment of negative and imaginary roots. Khayyam recognized these entities, but he did not fully integrate them into his system. His dismissal of them suggests a hesitancy to embrace concepts that lacked a clear geometric interpretation. These critiques, however, do not diminish the importance of his contributions. They highlight the evolution of mathematical thought, the ongoing process of refinement and expansion of understanding. The historical context of the treatise is critical for grasping its significance. The Islamic Golden Age fostered remarkable intellectual activity. Khayyam, a product of this environment, possessed a deep knowledge of Greek mathematics, and he built upon the work of his predecessors. He was influenced by the works of Euclid and Archimedes. He synthesized existing knowledge with novel techniques. Khayyam's contributions were not only theoretical but also practical. He was involved in the reform of the Islamic calendar, demonstrating his versatility. The environment allowed for the flowering of mathematical thought. The treatise is not merely a collection of solutions, it is a philosophical statement. Khayyam approaches problems with an unwavering commitment to logical rigor. This approach to problem solving, the systematic derivation of equations as meticulous geometric solutions, reflected a broader intellectual trend, an emphasis on precise reasoning's clear articulation of I. The legacy of Khayyam's treatise extends far beyond the specific solutions it offered. He provided a methodology, a framework, and a set of tools that would inspire and influence subsequent generations. His systematic approach to classification of equations and his careful use of geometric methods made a lasting impact on mathematics. He championed the pursuit of knowledge and the importance of logical deduction. The work of Khayyam, especially his treatise, resonates across time. It reveals not only mathematical genius, but also a profound understanding of the nature of human knowledge. It is a testament to the power of reason, logic, and the enduring human quest for understanding the world around us. The treatise stands as a remarkable achievement embodying the essence of mathematical inquiry, systematic approach to problem solving, and the power of combining abstract, though with physical models, all of which contributed to the advancement of human knowledge.